Okay, so we'll discuss addition polymerization. We have already discussed in the lecture the types of polymerization. So what I'm going to do here is I'll write down the mechanism of addition polymerization so that it will be more clear to you. The audio quality may not be very good, but please focus on my writing and then paper. If you have any doubts, then we'll discuss in the class. Okay, addition polymerization, as we have already discussed, it happens through free radical attack. Okay, so the free radical. So for forming a free radical, what we need is a initiator. Generally, initiator produces a free radical. These initiators are highly unstable, or they are susceptible to heat and any sort of radiation. It may be some sort of UV or heat. So they will produce free radical. So some of the initiators that we have already discussed, which is there in my PPT as well. So we discussed about peroxides. So they look something like this. Okay. So when they undergo free radical formation, then they are going to give R dot. So this dot stands for electron and OR another dot here. So there are two electrons in a bond. So when they break, so they will be divided into two species here, as you can see. But these species are highly reactive. So these unpaired electrons are not stable. So they will always try to connect with some other electron. Another is hydroperoxide. So this looks like this. ROH. This R is a alkyl group. It's mainly alkyl group in peroxide and hydroperoxide. Another initiator that we have discussed is known as benzoyl peroxide. How it looks like? It has a benzene ring. C double bond O, another O, and which is connected to another O, and then exactly same distance. So when this undergoes homolytic breakage. Homolytic breakage means it will be exactly breaking at this point. And you can see the symmetry in both sides, or maybe heat. So this is going to produce two this radical. Okay, so this radical is known as benzoyl oxy radical. Benzoyl oxy radical. Okay, so this radical will attack to a double bond, unsaturated double bond. So to make a polymer, what you require is an unsaturated bond for an addition polymerization. Right? So this we have already discussed. So let us take a simplest molecule, that is polyethylene or simply ethylene molecule, and we'll try to understand the mechanism. So generally this addition polymerization happens through 3 steps. Okay, 3 steps or 3 mechanisms. So the first is 3 steps or 3 mechanisms. First is initiation, second is propagation, third is termination. Okay, the first step and the first mechanism is initiation, second is propagation, third is termination. So the step 1, that is initiation, will be something like this. Now we take this as a R, simply I will represent as a R instead of taking a big structure, which I will say R dot. So when it reacts with this ethylene molecule, which is having an unsaturated bond, so this will attack to this unsaturated bond, and now this bond will break and create a free radical, which now will look like this. Okay, now this is the initiation step. In this step, this free radical attacks to a double bond to create a free radical of this ethylene connected with R. Okay, so the next step is propagation. Step 2. So how it happens in this one? In the propagation step, now you have R CH dot, which reacts with, let's say, n number of molecules. This is your monomer. This is the monomer. So this has many such kind of molecules in a solution, or if it is emulsion or any polymerization that it undergoes. So let's say it has n number of molecules here. So this basis now will attack to all of them one by one. It's a chain reaction. It's known as chain growth reaction as well, right? So it undergoes a chain reaction to give something like this. Now I directly write it here, CH2, CH2, say N minus 1, CH2, CH2 dot. Okay, so this is going to make a chain with having this number of monomer units N minus 1 and then a radical. Now as long as this radical is still intact, so we call this as a living radical. This one is until if this is still in the living, so the polymerization reaction continues. But if there are no more monomers, if for example all the monomers are consumed in the reaction, so now it has to undergo some sort of termination. Finally it terminates. So that's where the step 3. Okay. So finally this when this radical reacts with another this kind of a chain, then this finally becomes a dead sort of, it becomes a polymer or inactive polymer. It's no more active. It now becomes inactive when it reacts to another this free radical by a step known as termination. That is step 3. Okay. Now the step 3 can happen in 2 ways. One is coupling, like two this kind of radicals can connect with each other, and then the reaction will terminate. The polymer become inactive. Otherwise, they can also go another reaction called as a disproportionation. Coupling, or it's a sort of joining together, coupling or joining together, or another reaction disproportionation. So let us look here what is coupling reaction. So here if I take 2R CH2 CH2, I write maybe N CH2 dot. There are 2 molecules here, so that's why I am written 2. Now they will join. How it will look like? CH2 and CH2. Okay. Now you have CH2 here, CH2N. Another side we have CH2, CH2N. This one, and then CH2, CH2, which are joined together. So now it became a polymer chain, or you can say inactive polymer chain. There is no more active because it doesn't contain a free radical. So this particular reaction is known as coupling reaction. They join together. Okay, so one chain is joined with the similar chain, or it may be a different chain. It really doesn't matter. This is just a representative illustration of the coupling reaction. It may join with the same kind of chain, or it may join with some chain which is having m number of CH2. Really doesn't matter. So in that case, you can have m instead of n. Okay. The next is another mechanism, that is disproportionation. Disproportionation. So in this one, in disproportionation, let me take a simple so you have a radical like this. This R could be chain or maybe the initiator itself. Just a representation, it really doesn't matter. Or you can simply say this is a chain here. Plus R CH2 let's say you have radical like this. So now what will happen in the disproportionation reaction? Now is H radical will be transferred to this one. And now instead of CH2 here, it will be only CH, which is connected with double bond CH2. Okay, so one H radical from this H radical from this chain will transfer to this. Now this will be CH2, CH2 and CH3, right? So one radical, H radical will be transferred from here to here. So this is going to give now sort of two chains, right? Chain 1 and chain 2. So this is what is disproportionation reaction. In coupling 1, only the chain will be connected with each other to make this radical no longer reactive. And the disproportionate, only a transfer of a H electron, H dot will happen. Okay, so this is what disproportionation reaction. So this is all about the mechanism, the three mechanisms: initiation, propagation and termination. So initiation reaction happens only once, at once, like one initiator is good enough. Of course, you have many molecules of the initiator which will attack to the several other species, double bonds, to create many number of free radicals. And the propagation termination continues after that. But in addition, polymerization, this free radical polymerization happens within almost no time, at a very fast, at a very fast rate. So for example, if you plot molecular weight versus percentage conversion of the polymer, then this free radical polymerization happens almost, which is independent of percentage conversion. That means it happens within no time. In a fraction of seconds, the free radical polymerization happens within a fraction of seconds. Free radical polymerization. Whereas in condensation polymerization, molecular weight is conversion, this is quite slow. It will follow something like this. So the molecular weight buildup will be very slow initially. As the conversion increases, but it almost increases exponentially at higher percentages. And in some polymerization reactions where it happens slowly, and steadily until all the monomers get consumed. In that case, the reaction will proceed something like this. So the molecular weight buildup will be gradual, maybe linear with respect to the percentage conversion. Okay, so this is about how these different polymerization reactions and their kinetics. Of course, we have excluded all the kinetic equations here. Okay, so one more thing that I wanted you to discuss is the head-to-head and tail-to-tail conversion. Maybe I can show it here. Head-to-tail and head-to-head. So how, let me give an example. CS and you have X. Actually, this is a chain here. So X could be maybe styrene group or chloride or any polymer. Simply I just denote X for different polymers. Now when these polymers are connected with another this kind of, okay, let us first discuss head to tail. In this case, we have CH2, CH and X. Let's say you have a dot here, 1, 2, 3, 4, yes. So when this connects to the back side of the X group. So this is known as head to tail. R CH2 CH CH2 without here. So this particular attack, it's a backside. So this is known as head to tail connection. Okay. So similarly, head to head is now from this side. I will show you. Head to head. R CH2 CH X dot plus there will not be dot here. That's connected with X. Okay, so this is head to head reaction. Both sides you have, the connection will have X neighbor to each other. Right, so this is head to head. So most of the propagation reaction happens through head to tail, but some of termination reaction it has been encountered that this polymerization reaction might undergo head to head. Otherwise, thermodynamically almost all the propagation step undergoes head to tail. Unless otherwise, if intentionally we want this kind of configuration. If we want this kind of head to head configuration, then a special provision is made, maybe by using some catalyst or maybe by some other method to achieve this kind of reaction. Otherwise, thermodynamically it's always head to tail in the propagation step, but this might happen in the termination. In the termination reaction, this head to head is possible.